This is the second part of the Ranger Tugs 31 Sedan Northwest Edition factory training review. This section covers operations, including the engine startup procedures, the controls available at the helm for maneuvering and docking, VHF radio and navigation, anchoring, and elements regarding boat maintenance. As we go through the engine startup procedure, we'll cover the E key. That's the EVC system fob that you have on your keyring, and the throttle station and how we get that activated. The engine start procedure begins by opening up the engine hatch and taking a look around, inspecting for leaks. Then we're going to check the engine oil and coolant level. So in the lower left side of the picture, there's the dipstick for the engine oil. Just pull that out. Make sure that the oil level is in the proper position between the max and min markings. When you put the dipstick back in, make sure you hear an audible click as you seat it firmly. Then the coolant level, the knob with the yellow sticky on it, that is under pressure when hot, so only check it when it's cool. If it is cool, then you can unscrew that tap and then take a look and make sure that the coolant level is near the top of that expansion tank. While still down in the engine hatch, we'll verify that the seacock is open. That provides the cooling water for the engine. Then we can close the hatch and go over and turn on the engine battery switch. Moving back into the cabin now, we'll put the throttle lever in the neutral position. We'll use our key fob to unlock the EVC panel, at which point the ignition button LED light will turn green. And then we can press the start button until we hear the engine kick off. Just a quick note here, when stopping the engine, we use the engine stop button on the EVC panel, and then hold that in until the engine quits. Then press the ignition button until the green light goes off. Then it's important to wait 15 seconds before going and turning off the engine battery switch. If you turn off the battery switch without turning off the ignition button light, you'll get an error message next time you start up saying you didn't do the shutdown procedure properly. When turning on the EVC panel, the main throttle station is always activated, and you can tell that that station is active because that top center button has a green LED light on it. There's also an LED light off to the side that shows you that the throttle is in the neutral position. So if you need to activate a station, then you press that center button once and the light will turn green. If you press it twice, it will lock out other stations. So if you have a cockpit control wheel, then and you don't want the kids playing with it, you can make sure that you can lock that out in that process. And in order to switch control to another station, then both throttles at each of those stations have to be in neutral, and then you can press that station button on another station to activate that. There are a couple other buttons to talk about on the throttle. There's a low speed button in the lower left, and that is mainly for fishing. So if you want to troll, put out the downrigger and run at low speeds, it's appropriate for that. If you push this button, it disengages the prop every few revolutions and allows the boat to travel at slower speeds. In the middle on the bottom, there's a throttle only button. If you push this, it disengages the propeller entirely. And the idea is if the engines are running and you're out on the deck, or maybe you're messing with the anchor or putting out some fenders, and you don't want anybody to accidentally bump the throttle and kick it into forward or reverse gear, then you can push that button to prevent that from happening. There's a cruise control setting, so if you're driving along at a particular RPM, you can press that button and it will hold it at that RPM. And then you can move it up or down in 50 RPM increments by using a button on the front of that control station. Just to reiterate, if you do have another control station, then to transfer steering and throttle capability to that station, then you go to that top center button on the throttles, press that station button, making sure that the throttles are neutral in both stations. And then once you press that station button, then the light will turn green, and then controls will be active at that particular station, but not at the others. On the helm console is a 4-inch Volvo Penta display panel, and you can use that to display a variety of engine and vessel data. That's Also integrated with the chart plotter, so that information is also available on the chart plotter as well. The 31 is equipped with bow and stern thrusters. Those are very useful items for docking and maneuvering in tight quarters. The controls for these are located on the helm armrest, so the toggle switches can be used to bow or stern left and right. There's also a wireless remote, and that can be selected as operational from the helm. To use these thrusters, you have to turn the battery switches on, and those switches are located in the cockpit area under the sink. This is a side view of the bow thruster. It has a propeller that's located inside the tunnel there, and that propeller has a zinc anode attached to it. The thruster motor for the bow thruster is located in the forward section under the master berth. This is a view of the stern thruster. It also has a small propeller with a zinc inside that canister. The battery for the thrusters is located in the starboard lazarette. Each of the thruster motors has a shear pin that protects the motor in case something gets caught in the thruster propeller. If that shear pin shears, then the motor may sound almost normal, but no thrust is produced. That shear pin is held in place with a snap ring, and if you need to replace that shear pin, then you remove the motor from its mounting plate, making sure the power is off before doing so. The stern thruster motor can be accessed by opening up the hinging bench sheet, which exposes the compartment that the thruster is located in. In order to remove the motor from its mount, first make sure the power is off, and then you loosen the two bolts attaching the motor with the ratcheting Allen key tool. The tip from Ivan is to use that tool, loosen both of the bolts, and then while you're supporting the motor with your palms, use your thumb and forefingers to just unscrew and remove both bolts more or less simultaneously, and that allows you to keep the motor aligned evenly with the housing. Makes it easier to remove. The 31 is steered with a rudder. That rudder assembly is shown here, bolted to the stern. On the inside of the boat, there's an arm that extends out from that rudder, and that is attached to a hydraulic ram. And the hydraulics for that ram are controlled by either the Helm pump in the helm station or by the Autopilot pump itself. The steering is accomplished with a self-venting helm pump that's located in the steering column. That communicates hydraulically with the ram that we saw on the previous slide. That system should be inspected for leaks. Also, to do a steering wheel check, rotating the steering wheel and making sure that it smoothly goes from lock to lock without skipping around, and that it stops firmly at port and starboard at around 4 or 5 total turns. There's a cap on the steering column. Normally that cap is sealed in order to prevent a mess if the hydraulic fluid leaks out. But in an emergency, one can add hydraulic oil through that access port. For example, there was a leak and you lost steering underway, you could have some fluid to refill that system. The 31 comes with the Garmin Autopilot system. The control screen for that is located on the helm console. When it's operating, it attempts to continuously adjust the steering to maintain a constant heading. And in operation, the heading hold text appears in green, and the actual or the intended heading, which in 150 degrees in this case, is shown in the top center there. To change that heading, to go left or right, you can either use the plus or minus 1 degrees or plus or minus 10 degree buttons. If you want to disengage the system, you can press the red standby button in the lower left, and then the heading text will turn gray, and the red button now says engage. And then you can turn the wheel, let's say, to a new heading if you want to, and then hit engage, and it'll resume with the new heading, let's say 228, for example, in this case. The Autopilot uses hydraulics to communicate with that ram that controls the rudder. It has its own separate steering pump, and that pump is located in the starboard lazarette. The last of the controls that we'll talk about are the trim tabs. So there are 2 trim tabs located at the stern, both port and starboard. They can be helpful in trimming the boat from side to side if there's a weight distribution that is unequal, And also, as we're transitioning to higher speeds, by lowering these, it can help the stern, lift the stern, and help the boat get to that higher speed more easily. Located just down from where the propeller shaft connects to the transmission is a stuffing box, and that needs to be adjusted to keep the propeller turning smoothly and cool. And the process for doing that is described by Tim Bates in a spring maintenance seminar that they conducted as the Prop Turns video. We're going to reproduce an excerpt of that here in the next few slides.
Alright, so for our inboard boats, your boat has what's called a stuffing box or a packing gland. This is basically the seal from where the shaft goes through the hole, and it's what keeps that water tight. So, what is a stuffing box? The stuffing box houses basically a packing material which is used to seal the shaft going through the hole. It should be inspected and regularly tightened, so you always want to keep an eye on that and make sure that, number one, you don't have an excessive drip. It's not dripping too frequently, but you do want to see a drip. This should remain cool to the touch, so if it's overly tightened, you're probably too tight. If you're getting a lot of water in the bilge, you probably need to tighten it up. So this goes back to those rigid E110 offset X head wrenches that we talked about earlier, the 9.5 version. These two wrenches are what's going to allow you to tighten up that stuffing box. So on this slide we talk about how to adjust. So with one wrench you want to hold the stuffing box, which is the first one here. The stuffing box is the larger of the two, basically the adjustment nut. And then you want to loosen the locking nut, which is the back one here. So if you turn the locking nut towards the back of the boat while holding the adjustment nut here, that'll basically free these two from each other. With the locking nut loosened, you want to tighten or loosen that stuffing box until you achieve the right drip rate. So what you're looking for is a drip every 15 to 20 seconds while the engine is running and in idle gear. With the engine turned off, you shouldn't have a constant drip. If you're seeing a drip every 15 to 20 seconds with the engine not running, you probably need to tighten a little bit. To monitor the drip rate, you definitely want to have the shaft turning. So either do it at the dock with lines secure. I usually will go into forward idle and have somebody on the outside of the boat holding onto a bow rail. Make sure that the boat's going to rest nicely up against the side of the dock. Lines are tight. The other option would be underway. So if you're out away from the marina in an open area, calm water, you could always go into forward idle. Make sure you have somebody on lookout watching off the front of the boat. Once you have those, adjusted properly, you can use a penetrating oil. You'll see on the picture here, we have a little bit of kind of that bluish green look to this one. When they're new, they have a nice bronze, brass look to them. Over time, as it gets salt water down there, you'll see that happen a little bit. It's purely cosmetic. It doesn't hurt the stuffing box at all. But if you wanted to keep it clean, you could always hit it with a brass wire brush, use a little bit of penetrating oil and a corrosion spray on it. Penetrating oil will also help loosen these nuts up. So if they're really tight, you can always spray those down with some penetrating oil before you go to adjust. So over on the right here, we have a picture of how to adjust. So if you're loosening the backing nut here, you just want to hold the adjustment nut in place while you turn the locking nut down to the right. This is facing, the right would be facing the aft side of the boat. The engine would be over here on the left. So, alright, so if we just talked about loosening, so to tighten or loosen, once you actually have the backing nut backed away from the adjustment nut, at this point you're either going to tighten to get less of a drip or loosen to get more of a drip. On the left here you have a picture of how to tighten. So once the locking nut is loosened several turns, you can turn the stuffing box or the adjustment nut clockwise towards the back of the boat until you get that drip rate that you're looking for. Make sure to basically retighten that locking nut once you get the correct drip rate, and then that's when you would want to monitor that drip rate with the engine running and in gear. You don't want to adjust this with the engine running and in gear, so I'll always turn the motor off, adjust the packing, and then once everything's back to tight, turn the motor back on and go into forward idle. If you've over tightened, so you look back there, engine's running, you're in gear, and you're getting no drip, at that point you would need to loosen a little bit. To loosen, you would once again loosen up the backing nut away from the adjustment nut, turn the stuffing box counterclockwise or towards the front of the boat, and then retighten up the locking nut and monitor that drip rate. So, simply, if you're trying to tighten, all you're doing is you're turning the the adjustment nut towards the back of the boat. If you're trying to loosen, get more of a drip, you need to turn this larger adjustment nut towards the front of the boat. Are there any questions?
And that was Tim Bates giving us a run through on adjusting the stuffing box. The 31 comes with the ICOM VHF radio. It has AIS receive capability. It also has DSC calling capability as well. AIS stands for Automatic Identification System. Vessels that are equipped with AIS transponders can send out a signal that your VHF radio will be able to receive, and then on your chart plotter, the location of that vessel will be shown as a triangle. Green triangle with the arrow pointing in the direction that the vessel is moving. And then if the chart plotter thinks that it's a possibility that that's would intersect with your course, then it's shown as red with a line and an X where it anticipates that your vessel and the other vessel will possibly intersect. You can also click on these targets and get information about their location, how fast they're going. Oftentimes information about the vessel name is present as well. As this is a new boat, it's probable that you'll need to program your VHF with an MMSI number, and it's required for radios that have digital selective calling, which this boat does. It's also required to have an FCC issued MMSI number if you're going to operate outside of U.S. waters. So to do that, to get the MMSI number, the first thing is to get an FCC registration number. If you've had a boat in the past, it's possible that you've already got one of these, but if not, then go to this website and you can order one of these. If once you have that, then go to the next website and complete a application for a new ship station license. So once you navigate to that website, there'll be a tab there that says apply for a new license. So click on that, and they'll ask for a number of things like the vessel name, length, some more details about your boat. And then once you've submitted all that information, they will email back to you your ship station license and your new MMSI number. And then to program that number into your radio, there's instructions in the manual on how to do that. The 31 is equipped with a sonar transducer that's located under the floor in the galley. The users oftentimes set a keel offset so that the digital number that's read on the sonar display screen is actually the water, the amount of water underneath the lowest point on the boat. So the propeller on the 31. So in this particular case, the sonar is reading 26 feet of water depth with a 2.5 foot keel offset. The digital number is 23.5, so 2.5 feet less than 26. The sonar system is what's called an in-hull transducer. So it sends its signal directly through the solid fiberglass hull. The transducer sits in a cup filled with antifreeze, and because the acoustic properties of the antifreeze, the fiberglass hull, and seawater are similar, the sonar signal can travel directly through the hull to the ocean bottom and then back to the sensor with very little attenuation. If the sonar doesn't seem to be working as well as it normally does, then check the level of antifreeze in the cup and refill that if necessary. The 31 is equipped with a 180-gallon diesel fuel tank. That feeds the engine, of course, as well as the Webasto diesel furnace. There are two ways to get the amount of fuel that are remaining on board. There's a calculated method where the Garmin system takes the input fuel used subtracts that from the initial fuel that was reported that it started with, and then you get the number in the upper right there. That's 20 gallons. And then the other method is to use a mechanical float device that's located on a cinder in the fuel tank itself, and that one reads 21% remaining. That's the lower right-hand gauge. The cinder level itself has a number that locates where the cinder is placed. So in this particular case, that's at 2%. So 2% location in terms of how far away it is from the bottom of the tank. The fuel tank itself is located under a hatch in the galley. This picture shows the fuel pickup and the vent lines. Also shows a couple of the hot coolant lines, and those are the lines that come from the engine itself, circulating the hot coolant water to the water heater and the cabin heater. There is a shut-off valve so that you can turn off the fuel that's going to the engine, and that's this valve that you see here heading into the primary fuel filter. That's that white canister with the T-top there. A number of Ranger Tug owners use diesel fuel additives. One particular product that's recommended both by Volvo and by Ranger Tugs is Stanidine. It's advertised as having a number of performance enhancements. For navigation, the 31 comes with a 16-inch Garmin chop plotter that has GPS, sonar, radar. It's integrated with the Autopilot and the Volvo engine diagnostics and has full navigation charts for the US and Canada. The large 16-inch screen area of the Garmin chart plotter is really great for showing lots of details of the navigation maps. Users will typically place on the sidebar items like GPS speed, miles per gallon, fuel flow, the remaining fuel on board, water depth. And on the bottom section, for quick access, different features can be pinned, like radar overlays, sonar, fuel and engine gauges, active captain data, etc. The large screen size lends itself to setting up multiple data sets on the display. Using the combo feature, you can choose how to set up your screen. In this particular example, we chose a 3-part layout. And then once you have that selected, you can click on each of the panels within the screen and add whatever data set that you'd like. So in this example, we chose a nav chart, the sonar, and some engine diagnostics. But of course, you could have any one of these panels display whatever data set that you like. The 31 comes equipped with an 18-inch Garmin radome, has a range of 48 miles. The radar data itself can be easily displayed as an overlay on the navigation charts, which is great for those occasionally foggy mornings. For anchoring, the 31 comes equipped with 50 feet of chain, 200 feet of nylon line, and a 22-pound claw anchor. There's also a Lumar windlass for deploying and retrieving. The controls for the windlass are at the helm, as well as standard up-down foot pedal controls on the bow. The anchor windlass is set dead center on the bow. The line and the chain are fed into a chain locker on the port side. The circuit breaker for the windlass is located behind the helm. To test it, you press the red button and the arm should flip down as shown here. To reset it, just reinsert the arm up into the breaker. The pilot house sliding side door provides easy access to the bow for picking up a mooring ball or for anchoring purposes. There's also a cleat right outside the door for convenience in putting down a fender. To open the door, release that small silver lock and push down on the latch. When the door is fully opened, there will be a catch that fixes it into place. And so to release that catch and close the door, you have to push down on the sliding latch just above the handle on the side of the door. There's a spotlight mounted on the forward mast pole. It has a control panel that's located above the helm. You turn it on and off with the center button, and then the arrows allow you to directionally control where the beam is pointing. With regard to maintenance items, the service protocols can be downloaded from the Volvo Pinto website. Service intervals will vary for different items, but for things like engine oil, oil filters, air and fuel filters, it is generally annually or every 200 hours. One of the do-it-yourself items is to regularly inspect and clean the seawater strainer. It can accumulate bits of seaweed and other debris. So to do this, remove the metal retaining band and take off the plastic cap and pull out the basket. Once the basket's cleaned out, locate the two metal pegs at the bottom of the bucket and then line these up with the two corresponding holes in the bottom of the strainer basket. So when replacing the basket, this will ensure that it's in the right orientation. Over time, marine life and mineral deposits can build up in seawater lines. To mitigate this, some owners will do a freshwater flush of the engine cooling lines on an occasional basis. To do this, you can close the valve on the raw water seacock, open the top of the seawater strainer and put in a freshwater hose and get it running. Then you can start the engine and run it for several minutes. Stop the engine, remove the hose and replace the strainer cap and reopen the raw water seacock. There are two fuel filters that need to be changed at 200 hours or annually. A primary fuel filter, which is what's shown here in the white canister with the T-top. The process is written down here, but there's a really good As the Prop Turns webinar that Tim Bates ran a video on, and I refer people to that rather than trying to repeat the process here. And this is the secondary fuel filter. It comes after the primary filter and filters out the fines and also has the water in the fuel sensor at the bottom of this. The process for changing this is described here, but as I mentioned before, really is best to go watch that webinar on spring maintenance from Tim Bates. The engine oil filters and air filters should be changed every 200 hours. The air filter is in this black canister that's got the two metal latches on it, shown in the left-hand picture. And then there are two spin-off oil filters, and those have different part numbers and different hole sizes. So when changing your oil, make sure you get one of each. It is recommended that the fuel filter for the Webasto diesel heater be replaced or at least inspected annually. So in order to do that, we go to the fuel pump black box, which is located in the salon floor hatch. And then you open that up, and this is what you'll see, a fuel filter and fuel pump. If the filter itself will have diesel fuel in it, and if it's about half full, as shown, then the filter is still good. But if the container is full, which means the filter is clogged, then that filter needs to be replaced. And there is a full description of that process that is described by Tim Bates in the spring maintenance video on the As the Prop Turns webinar. Protective anodes are added to metallic systems on boats that are in contact with seawater in order to prevent galvanic corrosion. So in the electric circuit that's made up of, say, a bronze propeller, a steel propeller shaft, and seawater, the metal that has the most negative reduction potential will supply the electrons for the current in that circuit, and in the process, that metal will oxidize and corrode. So metals like aluminum, magnesium, and zinc have a much more negative reduction potential than any of the other metals that are used in boats. And so if an anode is made of one of these metals and attached to the system, then that anode will be the one that supplies the electrons, and that will be the one that oxidizes and corrodes. So the R-31 has 6 of these anodes. They're all made out of zinc. There's a cone-shaped one on each of the bow and stern thruster propellers. There's a flat disc-shaped one on each of the trim tabs. There's a larger dome-shaped one on the main propeller. And then there's also a large plate zinc that's located on the transom. The zincs should be inspected on a regular basis and replaced when they've corroded down to about 50% of their original size. The length of time that zincs will last is quite variable and dependent on what marina that the boat is being kept in. One of the maintenance items is to occasionally check the bilge pump motor housing to make sure that there's no debris in there. So there's a nice As the Prop Turns webinar, that spring maintenance one that we've been referring to, where Tim describes the process for doing that. The transmission oil and filters have a service protocol that recommends changing them after 6 months or 25 hours. That's the initial period. and then after that they're changed to 200 hours or annually. This concludes part 2 of the factory training review. We hope you have fun on your next Ranger Tug adventure.